increase the height of fresh water because you lower the water table, it happens that this particle raises up, moves up, because the pressure of salt water is higher than the pressure of fresh water. Now we can write an equilibrium here. We can write this equilibrium condition. And if you write the equilibrium condition, basically the same situation is reported here. Here it's more understandable. It's always static conditions. It's more understandable because it's easier to understand this sketch with respect to this one. But it is the same situation. If you put in two communicating pipes, salt water and fresh water, and you don't have any mixing, you wouldn't see the water at the same level in the communicating pipes. The fresh water level would need to be higher in order to keep the equilibrium here. Okay, now let's write this equilibrium condition. If I write the equilibrium condition, I simply write gamma F times HF is equal to gamma S times HS. So let's compute HS, because I am interested in locating where is equilibrium. And in order to locate where is equilibrium, let me compute in an explicit way HS, because the seawater level is fixed, on average is fixed, and therefore if I compute HS, I uniquely locate the position of this particle, and therefore I can write that HS is equal to gamma F divided by gamma S times HF. If you take into account that if you take into account that gamma F is equal to 1000 and gamma S is equal to 1024 cubic meters, kilograms per cubic meter, you can put a direct relationship here between the two. Which is something like 1, okay. We can write here gamma S is equal to 1 divided 1.24. Okay, so HS is equal to this number multiplied by HF. And therefore we can uniquely locate the position of the particle for different depth. So if we want to locate the position here, basically we have that HS is equal to 0. And HF is also equal to 0 because they are so the result is trivial. They are the same particle, but if we start increasing HS, for increasing HS, we see increasing values that we need of HF. And therefore, the result, if you make these calculations, if you assume a position for the water table, and if you repeat the same calculation for increasing value of HS, you see that the resulting shape is a wedge. Let me check whether I use the same symbols. Okay. Yeah, not really, because what I used as H, no, I didn't use the same symbols. So sorry for that, but the conclusion is the same. I used here, basically, I used H as HS that I indicated before. HF is the same symbol. I changed this one. I changed this one. Anyway, it's more or less the same. You need to change symbols with respect to the blackboard to the... Okay, let's move forward. And, okay, first let me anticipate. I asked you to bring the PC today. I realized that I can't move forward with exercises, so let me make the plan for the next week. Next week we need to finish this very briefly, but please on Monday bring your PC as well, because my plan is to make another exercise, another couple of hours of exercises before closing the classes, and I think 1 hour on Monday is doable, and then we continue on Tuesday. And also on Tuesday I want to take at least half an hour time in order to give you some final recommendations for the exam, making a summary of our interactive activities. So again, I'm continuing now for 20 minutes with some further discussion on saltwater intrusion, and then on Monday we conclude this part, and then we start make some exercise, and my plan is to make an exercise on the computation of the salt wedge by applying this formula. So I give you a practical exercise which is simple to make, but it's also an opportunity for us to reflect some more of what we discussed today. And then my plan is to continue on Tuesday, and then on Tuesday to keep the final part of the lecture to make a summary. Okay, now I think for this analytical part, let's stop here, and then we get it back again on Monday when we make the exercise. And let me discuss some. This is another picture on drivers. Let me discuss about monitoring and remediation. So, monitoring and remediation. Monitoring, first of all, in order to assess saltwater intrusion, we need to monitor groundwater. And this is particularly complicated because with respect to rivers, we cannot see groundwater. What we need to monitor is the groundwater level and the groundwater salinity. Monitoring can be extended to rivers, and in this case we monitor the salinity of rivers. Monitoring is important because we need to realize in advance with a good lead time when saltwater intrusion is taking place. We need to realize it in advance because as I said, to recover the aquifers is extremely difficult, and therefore we need to be very timely. Of course, when the salinity is very reduced, it's not yet a concern, but it's important to get the signal, preliminary signals, which alert us and give us the warning. And monitoring is, from a technical point of view, it is essentially simple because it's measurement of groundwater level, and it means taking groundwater samples which typically are taken by wells, which is technically simple. But the problem is that we need a monitoring that is diffused in space. Because we know that aquifers are heterogeneous, and therefore, if we want to get a representative overall picture of an area, we need more monitoring stations. We need a lot of monitoring stations, several of them. Several, because otherwise the heterogeneity of the aquifer, and therefore the heterogeneity of saltwater intrusion, may induce us in a mistake. The problem is that usually wells are not so dense, usually the wells are sparse, and therefore a solution is to install piezometers. Piezometers are like small wells, so basically we put into the soil small pipes which have a depth, they need to reach the depth of the aquifer, and they need to go into the aquifer well into it, so for a good depth. And we need to monitor the aquifer at different depths, because you have seen that the wedge, the shape of the saltwater intrusion is a wedge, and therefore we need to monitor salinity at different levels into the aquifer. But these pipes are relatively small, and they are not expensive to be put in place. The only requirement, the only expense which is significant is related to actual monitoring, because we need to monitor groundwater with frequency in time that is usually quite high, quite relevant. I want to give you an example of monitoring. Let me see if it is here. No, it's in the web pages. Just 1 second. I think I have some examples here. Yeah, this is an example of salinity monitoring stations in the delta of the Po River. And you see that there are stations along the river. The Po River has not an estuary, it's a delta. It means that the river splits in several different branches before reaching the sea. And the reason why it splits is that there is a sediment delivery from the Po River that is very relevant, and therefore the sediment delivery origins the delta, and the deposition of sediment causes the river splitting in several branches. And the monitoring stations are placed, some of them along the river, and some of them into the land. And here I think this map visualizes only those that are placed along the stream network. You see that there is a monitoring station of salinity also into the sea. You need a baseline of comparison, and the baseline is the salinity of the sea, which is not the same different places, of course. And in this case, and here I expect that the salinity close to the delta is lower on average with respect to the salinity of the Adriatic Sea, because there is a mixing by fresh water. And the Po River always has a significant flow, even during summer, into the sea. What we expect to see is a reduction of salinity going upstream, and therefore they obtain several pictures in different periods of the year, and especially during summer they compare the salinity on the river with the salinity of the sea, and the salinity that they detected in different seasons. This is a typical scheme, and It is completed, this network, by a network of piezometer and wells. In this way, they can get a picture of salinity along the river network and in the aquifer. And this is a map of salinity referred to a particular day, which was August 9, 2012. You see the different colors. Light blue is fresh water, dark blue is salt water, and you see the progressive change of the colors, which means a picture that is easy to understand, and it's nice. There are other examples of pictures like this in this website, which is a public website. It's a nice example of how to visually compare salinity and saltwater intrusion in different seasons of the year. Now let me talk a little bit about recovery, and which is, as I said, a delicate issue, and usually it is the phase where we are asked to give our opinion through consultancy. First, in order to understand what is the best action to recovery, you need to understand what are the drivers of saltwater intrusion. This is, of course, trivial. And so, is it anthropogenic influence, like overexploitation of groundwater, it's sea level rise, it's subsidence. Typically, in this area of the Adriatic Sea, in this region, the main drivers are subsidence and overexploitation, with overexploitation prevailing, being particularly effective during summer. And then, once that you understood the drivers, you have also to inquire whether it's possible to recover and in what time. Because in some cases, recovery may be not the best option. In some cases, you may prefer to adapt to increased salinity instead of recovery. It's like for climate change. You have the option of mitigate it or adapting to it, and in some cases, it's better to opt for adaptation. And the effect to recover from saltwater intrusion fall into three overarching categories. And the first is modification of groundwater and surface water withdrawals. The second is modification of groundwater and surface water deliveries. So if you increase the flow into the river, of course, or if you increase infiltration, of course, it's an action, infiltration into the aquifers, it's an action that may allow you to recover, and also engineered structure like sheet piles. Do you understand what is a sheet pile? It's like a wall that you put into the soil. It can be made by metal. It's a barrier that you put into the soil. It can be made by metal or concrete to artificially construct an impermeable layer. So if you build a sheet pile and you go into the deep underground, and it's possible because sheet piles potentially can reach very considerable depths, of course you create an impermeable layer and you stop saltwater intrusion. And the question is how much deep should we go, which is a relevant question, of course. This table is taken from a contribution about the impact of saltwater intrusion in coastal regions and provides a summary of and references. The actions are those that she also summarized during the presentation. So you may decide to change your policies for groundwater exploitation. For instance, in the Romagna region, about 40 years ago, they decided to build the Rivracoli Dam, which some of you may have visited with other professors. And they decided to build the dam in order to get fresh water to feed the coastal areas therefore reducing the groundwater exploitation. And this was done with the aim to recover from saltwater intrusion, among the other things. This is a possibility. Another possibility is artificial replenishment of groundwater resources. If you opt for this solution, it's extremely important that you try to understand, either through models or through conceptual reasoning, the functioning of the aquifer, because in coastal areas it is highly likely that the aquifer is not confined. In alluvial areas the aquifers are very extended, and therefore the implication is that you may need a lot of artificial recharge in order to modify the storage in an effective way. We don't realize it, but when we take water from groundwater, usually we withdraw important volumes. If we want to give these volumes back, we need continuous replenishment, which is not easy. In some cases, you may decide to opt for not for recovering, but for retreating a little bit. Retreating means that you may decide to find alternative water sources. In this case, you of course decrease the groundwater exploitation, but also if you don't rely on groundwater anymore, you are less concerned by saltwater intrusion. Saltwater intrusion, basically, why it's a problem? It's a problem because of its ecological consequences and its consequences on the health of humans. If you are not concerned by ecosystems, for instance, because you don't have rivers that are affected, it's just groundwater, and groundwater, may affect ecosystems, but only at a very superficial level. When groundwater is very close to the soil surface, then it affects the ecosystem. If saltwater intrusion is very deep underground, it's a problem if you want to take fresh water from there, but ecosystems are not really influenced. So you may also opt for a solution that is not really recovery. It's just dealing with a saltwater intrusion with some salt contamination by finding alternative solution for water supply. And this is certainly an opportunity. And it's something that is similar to retreating when you are threatened by flooding, coastal flooding or river flooding. Some people decide, instead of protecting against flood, they decide to leave, to retreat and to settle down at a larger distance with respect to the danger. And this is the same solution that we could apply with respect to saltwater intrusion. If we realize that recovering is impossible, we just leave it as it is, and we try not to interact with the risk anymore, finding alternative water sources. This is certainly an opportunity. I would say that, do you have any question? No? Let me say to conclude that, once again, on Monday we will make an exercise, and I think I am planning to summarize once more the sketch that I made for completing the position of the wedge, because I realized that this sketch was not really effective, so I would like to bring another one which is more meaningful. Okay, if you don't have any question, I think